Yes. So in the last class,
you were having these PPTs updated 10 months ago. They are the same
model tools. Just a second.
it was on the row.
Ah, plus 20. Plus 10 is application. The remaining 20 out of data, out of data, 18 is our master. 20 is just one master. Correct. Plus 10 or 10 will make it total 18. अभी इसमें नहीं डालेंगे यहाँ 80 का एड्रेस डालेंगे हाँ हाँ इसमें एड्रेस डालेंगे for a whole application part of yes, you say something. Okay. Linear transformation and matrices. I mentioned last class. It can be also be seen as simple function. In a function, we usually have a scalar values as an input to our function. Okay. I hope all of you have understood the graph that I drawn in the last class, and I have told you how vectors are getting stored on a graph plot of x, y axis. Right? Okay. N samples. Just merge it. When they merge it, these new samples are actually complex numbers in Fourier domain. Okay, that's thing. With complex numbers, we can capture the amplitude in the frequencies domain and phase time of phase angles or time shift of our original input signal. Whenever you merge them or whenever you do the operation between the vectors, you are going to transform that vector into a same vector without a change in the quantity, that is magnitude, but only the direction you are going to change. That's what we are trying to mention here. Same thing, if I tell you in terms of signals, what they are saying, here we can focus on the statement, this focus on. With complex numbers changing, we can capture the amplitude, that is the last peak value, the top value, amplitude in the frequency domain. homogeneous structure gets changed. I mean, half plus x and minus y, I'll be having some point like this with the plus axis and minus y as changed the value. That means I have represented phase. Wherever you want to find it, it's same. Okay, that is our time shift. To draw those each points, there are a lot of points are there. If you want those fine lines, the curves, you need a lot of points. So other than that, just for experiment, they're just taken up the important points which we are able to consider. All right, you can take a lot of points here. Here, everything here continuously you can take the points, and we are able to do that in the computer. You can draw the sine waves. Okay. Import numpy as NP, scipy as SP, and then dot pyplot and plt. Then percentage matplotlib dot inline. Then we have np dot array a range in numpy. This is going to generate the 8 numbers as an array, and that will be added to the k. And np dot cos, then this 2 into k, which are my values. That's pi value. If you know it, you can directly write the pi value. If you want to access it from the numpy, you can directly access from numpy. It's available on the plot here. Okay, plt.stem, which is this plot, k comma x comma use line collection equal to true. I mean, line collection is this line, and when you do that, you'll be able to see this type. will all of you do this? Just see how the wave mentions it. And I want all of you to change the without which you will not be able to calculate the curves. Okay, area of circle is very for us. Somebody have invented it and they are given and they are able to successfully make measure the area. If I give the scale, you cannot measure. You can measure, but you'll measure 95%. 5% you just leave it because some of the areas are very small. You cannot measure it in the scale. Very small. So I have to measure with a curved surfaces. So in that case, we need every time when you curved surface and you see pi, you definitely understand that okay, pi is participating because there are curves in the figure. Okay, the formula is there. Getting it? Okay, this much you need to understand. Okay, let's go ahead. Import numpy, scipy, and matplotlib. If you are not imported, import with the pip command. Okay. So go back to your terminal and you can install and see in which environment you are presently. So, then you can change the value to your zero channel 4 make that as 2 times. That was 4 the 8 0, 8 0.8 5 not 5 divided by 4 make it divided by those are not installed, you can install packages first, and then if you show and if you see an error, just let me know.
To start a
Start.
this. There we have to put one star between K and NP.
Just a second. Where 2 star K star. This K is not defined.
Yes, sir.
K is this one. If it is here only, then why it says not defined? That is the case sensitivity problem. Got it all of you? All of you?
So it's telling you import numpy as entry.py. Import numpy as entry.py.
What you're getting here?
I will not import numpy as NP, sir. Shall I
Okay.
make it NP.py? Shall I make it NP.py? Yes, import numpy as entry. So what? In the way pivot format, sir. The same thing, I'll get, or we can even assign it a variable, sir, and then we can create a.
Yes. So what have you got output? Yeah.
So why it is not running in 3.11 conversion?
It's not 11, it is not running.
So we got the same error.
What is the error? One thing. Go for the terminal. Go for terminal. Okay. Conda space list. Press enter. You are presently in the base, right? 3.11 only base. Press conda space list. Next cross link. Go for the yes. Please. So last name is there. So go for the yes here. Cypher. It's not set. There?
Yes.
Then it should not give any problem. Module not is the same. Let me check again. I'm getting the plot. So it is error or warning means something is going outdated. Something is going outdated, right? It's coming versions. So don't use that. So it is asking you to replace something. Depreciate means it's getting old. Error. Module not found. Uh, okay. So only in that you are getting or in any other versions? You are getting because it's usually same thing. Nothing new in that. Restart your internet. Let's see. Close that app. Open again. Let's see. When you change your A range, that is number of points that you want to consider, your precision of your graph will change. For example, I double it to 16. Of waves, that means the frequency will change. Same like the number of cycles are more. Frequency is increasing. If you change the first parameter, what? There are a lot of, and if you change it to this one, we'll make it 2, and you'll see there are points are available only on the either side of it. The sharpness of the curves will be missing actually. To make it 4, this is 5/4. You understand pi in terms of angles? 180. Okay. So in terms of wave, if I ask, do you understand in this one what is 180? I'll just play once again. Okay, I'll keep this graph and ask you the question. Do you understand that? Okay, so that's why they have the spring like behavior of electromagnetic waves. So here we're talking about 180 degree. When I make one wave divided by 4, I'm making my this one divided by 4. Points I'm trying to divide. Okay. Okay. What angle I can write here? 5/2. Okay. So this is the 0 degree. This is 90. And this is about 5/4.
This is 3
That's 5 plus 5 plus
Divide
5 by 2.
You already crossed 5 divided by. You just need to multiply. Right? Not multiply already. 5 equals to this. You cannot some small, right?
That is 3 pi by 2.
3 pi by 2.
Yes.
How much will be 3 pi by 2? 270.
Yes.
270.
270.
270 sir.
270. Other 270. I'll not confuse it.
360.
Okay. So whenever you're making a 5 by 4, you're actually making that 45 degree change in terms of the points. Okay. That's why these points are coming, but there will be points available to connect with this thing. Here we cannot show you how the points are in between because we don't have the floating point values here. We just have exact values. This is 1, this is 0, this is -1. Okay. If we had the floating point values also available for us to plot, then we would have developed the whole wave here. Fine. To do that, we have a different program. We did that. Let us take the program. The smooth curve that you can plot like this, you can move with all the floating point values, and you can move with the smooth curve with the help of this one. XY axis, plotting the sine wave. You need to create the A range. Now A range is little different. A range we had was 0,8, which is having range of numbers. Okay, 0, 1, 2, 3, 4, 5, 6, 7. All right, 8 numbers. So here we are saying pi into multiplied with pi. So these are my fraction values I am going to generate. Comma, this is my step angle. Step angle. That's my step value. So that step value is so small that it can increment so small that you see a smooth curve being added. I mean, so many values are available. You can draw the curve so smooth by just making a small changes each time. All right. You understand that? Yes, no. It's same like Rangoli that you had. If you take more time, you will have a curve. If you want to draw a straight line, you take more time. You just directly go. Getting it? If you want to draw the curve, you need a lot of points to be added. Is that right? Same thing. Nothing more. Okay, let's do this also. Quickly do this. You import both the package in a new cell. Right? As np matplotlib.pyplot as plt. Same pronoun also you can copy paste because almost same. We're just using sign here. Earlier we used pos. Starting value of pos is 90 degree.
So what we have to import here, sir?
No, nothing. Same NumPy and matplotlib. Only scipy is not there. Same program. Same program. These two things, scipy will not come, and immediately we'll have np dot a range 0, 5 multiplied with np, 0.1 will be my angle or a set count. Okay, as you write it, I will just load. Okay, writing it. Quickly do it. Fast. Same thing. 0, 8 was remove that 8 in the copy program. 5 cross 5 multiplied with np dot 5, 0.1, that is x value, and y value np dot sine of x. So giving that x values, all the values to be plotted in terms of sine. And at last, you are ready with the sine values and you're ready with the values that you are plotting. Are you ready? This?
So that time stem was there, and now the stem is not here.
You can plot in, presently we are not plotting the stem. We are plotting the graph. XY, generic X clear in
Sir, again.
Yes. How many parts are there?
All of you have done this curve. As you just saw, you see the difference between your sine and cos. So then you use the sine, and it started from this place, from somewhere one. All right, let's get back. Okay. Yes, input vector and output vector. When you see this one thing, that is 1, 2, 3, are the values of a vector on 3D space, and you are applying a function, and that function, this will be the input vector, and then this input vector is getting manipulated to this vector, 2, 4, 6. Okay. Now, let's understand what is this 1, 2, and 3. Can anybody tell me what is this 1 with the studies class? X-axis. X-axis.
2 is y-axis.
Y-axis. Exactly. So 1 changed to 2, 2 changed to 4, 3 changed to 6. The point has got changed. Okay, the address of the point has got changed. That's what the output vector is. It has just changed the direction, does not change its magnitude. That's what we're trying to justify here. Okay, let's read again. To make things simple again, we forget on complex numbers and we observe again our 2D coordinate system, that is x and y values. X, y coordinate. Alright? Okay, if we map this vector to another one, we say that this is actually a transformation. If you map the same vector with another one, they say it's a transformation. We did that earlier by manipulating the vectors, addition of the vectors, multiplication of the vectors. We did that, and we told that whenever you add or multiply, the vectors change their values. But at the end, the result is vector itself. So answer is vector itself at the end. Alright, the values might have changed, but at last we'll have moment or displacement. The total displacement. With a linear transformation, we are moving a vector again in our plane, that is 3D plane, to get our output vector. Vectors, and by transforming them, we are actually moving them in some particular way after applying the function. Just analysis movement or displacement. Okay, let's draw that and let's understand. Okay. Earlier we had a 2D plane. 2D is three, 4. Next, we have the z-axis as 6. So 1, 2, 3, 4, 5, 6. So this is my 6. So here, if I have it in 3D space, I can't draw it like that, but I'll point to here. This is my vector. But it is transformed according to this scale and this scale. This is my 2, and this is my 4. Not there. Only the linear increment is there. Okay. Okay. Therefore, program vector equal to np dot array, then minus 3 and 2 in an array. So what will be this minus 2? Where they will lie in the coordinate? This is my minus x. All right. If I consider this is my origin, as I have 0 here, I have 0 here, and I will, this is my okay. This is my 0 and this is 0. Here at the middle, and from here, this is my y-axis. This is my minus y-axis. Plus x, this minus x, because I have minus 2, minus 4 frequency numbers. So my value is minus 3. This is my minus 2. Somewhere here I have minus 3 in terms of x. And I have 2 here, that is positive 2, that's y is positive. If this y is positive, it must lie on any of these angles. So here, so I have this point. So this minus 3 and 2 are joining here. So this vector is actually pointing here. Okay. That's what we are trying to point and draw a vector on a plane. Vector equal to np dot array, and in two-dimensional array, we have minus 3, comma 2 as a tensor. Origin np dot zeros. Np dot zeros is nothing but this is the method which will fill your matrix called vector dot shape as a empty zeros. I mean matrix with the zeros. No values existing. It is like initial value. Like for example, I am making some I, like I will be my program. I'll make it I equal to 0 initially. As simple as that. Alright?
Initiate x1 y2 0.
Correct. So that whole matrix. Okay, so that's origin point I want. That's why origin point I am going to define with the help of origin. Origin I can define with the 4 values as zeros, np dot zeros. Next, this shape, when I say vector or shape, what is vector here? These are the vector here, these. Alright, this having these two values. That's coordinate obviously. And that is not only coordinate, that is a matrix. You can see those outside brackets here. Right? That's a list actually, a list of 2 dimensions. See, that's why I'm considering it as matrix. So that we are calling it as, making the dimensions being fetched from the matrix, from the list. That is shape. Shape will help you in finding out the order of the matrix. I hope you understand order of the matrix. Row into column. Okay, m into n, x into y, whatever you take it. So PLD dot figure, the same PLD. So plot, matplotlib.pyplot as PLD. PLD idea, that is your this whole vector actually. So origin we have to give, then vector, and then we have this is having a lot of parameters. These all parameters are representing something. A lot of parameters. Okay, let's go there and come back to the problem. Okay, it's basically the vector lines as arrows. Vector lines as arrows. This type of plots are useful in electrical engineers to visualize electrical potential and show stress gradients in mechanical engineering. You understand this? Vector lines as arrows is going to show. That's why this QR plot is being used. Okay, it's a type of plot whose work is to plot the points on the 2D space. That vector will be presented on the plot with the help of this keyword with a lot of other points. Okay, let's understand. And they're telling in electrical and mechanical it will be used. Electrical for electrical and mechanical stress gradient. Okay. X and Y, X position, Y position are starting points as we have taken vector and origins. Starting positions of the arrows, while X direction and Y direction are the directions of the arrow or where it has to go. That is -3, 2. All right. And then we have X position, Y position equal to 0. That is the origin points. And the direction of the arrow is pointing towards the upright, that is x direction equal to 1, y direction equal to 1 on the positive 1, 1. We don't have the parameter. Let's fetch the parameters.